The human body depends on two forms of energy production to facilitate physical activity: aerobic and anaerobic. While these concepts are easy to understand, most people haven't been adequately informed about how and why each form of fitness is essential. In aerobic exercise, muscle activity is fostered by the combination of the calories that we take in and the oxygen that we breathe. When you increase your activity level, your breathing rate increases because your body needs more oxygen to break down stored energy. The lungs work harder, which fuels the heart, which distributes oxygen to the muscles. Humans are specialists at utilizing aerobic energy for long-duration activity. That's believed to be one of the evolutionary advantages that got us where we are today. While humans were rarely stronger and/or quicker than their prey, they had the advantage of being able to hunt prey for long periods of time, exhausting the animal. Of course, aerobic energy isn't perfect for everything, which is also why we can generate power when the body needs more energy than oxygen can provide. This is known as anaerobic muscle activity. Anaerobic energy generation is required for bursts of strength or speed. The body can only sustain anaerobic exercise for so long before it must relent to fatigue, however. If the heart and lungs can't match the body's energy requirements, this leads to lactic acid buildup. This leads directly to an increase in pH levels in the blood. The human body has strict pH requirements for normal function, so the body can only withstand anaerobic activity for a short period of time before having to shut that system down temporarily for recovery. There are two factors which contribute to an individual's ability to withstand vigorous activity without succumbing to fatigue. The energy has to get to the muscles, and the muscles have to be able to utilize that oxygen in adenosine triphosphate, or ATP, production. All human activity is the result of chemical reactions, which contribute to ongoing function. In fact, the body is always producing a constant stream of energy 24 hours per day. There are three ingredients which are essential to providing energy: fat, carbohydrates, and oxygen. As long as these ingredients are available, the body can produce the power to meet its ongoing needs. Of course, protein is also important, but is not essential for the creation of energy. In fact, if the body takes in more protein than it requires, then it is simply converted into a carbohydrate or fat molecule. As you can tell from our description, aerobic energy production is excellent for producing a constant stream of energy. The problem is that producing energy from oxygen takes time. It may not seem like a long time, but when the body needs a burst of energy, aerobic conversion simply won't cut it. That's why the body has an anaerobic backup system. When activity levels and energy requirements increase abruptly, anaerobic energy production increases to help the body adjust to these changes. Anaerobic activity either slows down as aerobic capacity catches up to energy needs, or the body has to revert to a lower level of activity. As exercise begins, the body expends reserves of energy that are immediately available without the need for oxygen. During this phase, glucose and glycogen are the anaerobic sources of the available energy. The liver can quickly deliver glucose to the muscles, and glycogen is readily available in muscle tissue. The problem is that these reactions produce lactic acid. While the liver is capable of taking lactic acid and reverting it to glycogen, this process takes time. As the body grows accustomed to the requirements of the activity at hand, oxygen production rises to meet the demands of muscle, which is achieved by a concurrent decrease in anaerobic activity. In the case of light exercise, aerobic activity has the capacity to meet 100% of the body's energy demands. As the body gets used to ongoing activity, the liver begins taking stored glycogen from lactic acid and converting it into glucose. This helps the body sustain anaerobic capacity during aerobic activity. While anaerobic activity prefers sugar and carbs, the aerobic system prefers fat for energy production. As exercise continues, fat cells adipocytes, secrete fat to facilitate continued production of energy from oxygen. If exercise continues to increase in intensity, the body has a means to further amplify energy production. Unfortunately, aerobic capacity is gated by the body's ability to extract carbon dioxide through respiration. As the body's ability to produce oxygen and release carbon dioxide increases toward its maximum output, the body increases its reliance on anaerobic energy production. Activity which puts intense strain on muscle tissue leads to the compression of the tiny arteries which feed the muscles oxygen, which leaves the muscle itself to produce its own energy for lifting heavy weights, sprinting, etc. This can only go on for so long because it leads to lactic acid buildup. This impairs the ability of the body to meet its aerobic energy demands, which triggers exhaustion and fatigue to give the body time to recuperate. The liver only converts a portion of lactic acid into glycogen, which means that there are diminishing returns for anaerobic activity, which eventually means that activity must eventually slow down or cease to allow the muscles to rebuild their anaerobic energy stores. If you found this video informative, please press the like button and subscribe to the channel. To learn more about health and wellness regarding hormone replacement therapy, please click the link below in the description.